So in this video we are going to understand about video streaming using RTSP and RTP. But first we will understand about RTSP protocol and RTP protocol. So RTSP protocol is a real-time streaming protocol, which is an application layer based protocol and is used to stream videos on the internet. And this is the working of the RTSP protocol. In this, the client will send a describe request and the RTSP server will send replies containing the information about the media that we have requested, and then after the client will send the setup request. So the server will start a new new RTSP session, and then the client will send the play request to the server. Then there is a data packet of RTP transmission start and the video will start. And in between the client can send a pause request, so the video will be paused, and when the client will send tear down request, the RTP transmission will be closed. So now we will understand the RTP protocol which are used to transmit the data frame. So what is the need of the RTP protocol is that when we use TCP protocol, it provides reliability, but it requires more time because it needs three-way handshaking. And so in the video we will have to buffer. Our video will buffer because there is a delay in the packet transmission. So we use a better UDP protocol which will faster than the TCP, but we also want reliability. So we add RTP protocol over UDP layer, so it will provide reliability by detecting packet loss and out of order delivery packet. So this is the structure of the RTP header, which is of 12 bytes. The first one is the version. It will indicate the version of the RTP protocol we are using. Then this contributor count is basically the how many contributors are contributing in this RTP packet, means number of sources. Then the payload type is the which type of media we are expressing or we are requesting. Then the sequence number is the data frame number. From the sequence number, the client will know that the packet is get lost or it is out of delivery. Timestamp is the time, and the synchronization source identifier is a unique identifier for the source, and the contributor identifier is the how many, like this contributor count will have like four contributors, and there will be four contributor identifier. So each source has a different identifier, so these are their contributor identifier. So now we will go ahead with the Python code. So now I'll first start my server with the port number 1040. So in this server code we have assigned a server port from the system argument, and then created a RTSP socket which have address family as IPv4 and socket type as TCP IP. So now we will bind this socket and bind this socket with this server port that we have get from the system argument, and this listen will now be like how many clients we will have. So 5 clients at a time we can handle, and then this while loop will run, and we will storing when the client will accept our request. Whenever the client will connect with our server, so we will uh, store the client information in this client info directory, and then we will run the server worker class. So now we will understand the server worker code. So in the server worker code, these are the variables that we have defined for the our use, that we will understand uh, eventually. So first this init will called and the client info will be provided. Then the run method will be, we are calling the run method from the server. So it is so every client will assign a different thread, and it will go to the receive RTSP request. In the receive RTSP request, the server will wait for the client to send the RTSP request. So now we will start looking at the client code. So this is the client voucher, and launch the client. Right, so I will launch the client first. So we have given localhost because our server is running on localhost and it is running on port 1040, and we are giving RTP port to 1041, and the file we want to run, so it is JPEG. So now we are running this client. So this is the GUI will open, and we'll understand one by one what the things are happening. So in the client launcher, when we have run, we have given this server address, port, RTP port, and file name as system argument, and then we have created this uh, object of client class. So client class will in client class this init method will first call, and in this the create widgets call first. So the create widgets will build the GUI that you have seen here. This UI will build by this create widgets where the this is the button. This function will create the setup button and it will put text as setup, and when we will click that setup button, the setup movie function will work. So we will learn this request one by one. Like first we'll run the setup request. So let me run the setup request on this, and you can see this setup data sent and data received. So we will understand what this means. So when we click the setup button, this setup movie function called, and in that it is stating that the state is an initial state. Then we send the RTSP request to the server. So this RTSP request function is here. In this, you are also checking that the request code is set up, and then the state is init state. Then and uh, while sending the request, we are also starting a thread that will run in background. So it will wait for the RTSP reply for this request. Then we will increasing the RTSP sequence number, and this is for the formatting of the request that we are sending to the server. This request is basically this data sent format. So like that, and this is the we are tracking the request that we have sent. So this is the setup request, and this from this function we are sending the request to the server by encoding the string into a byte. And so here the server is in receive mode. So when he receives this data, he will print this data. So we can see here that this data received is print, and it will process this RTSP request. So when it will go to this process RTSP request, it will first figure out what is the request type from the request the client has sent, what is the file name, and what is the sequence number the client has sent. And this request type, we are again checking that if is the request type we have get from the client is same as setup, and the state is init state, then we are processing the setup. And in it, this is the video stream of we are creating a video stream object. It will do like here it will do nothing, only it will open the file that we have mentioned. We will see what this video stream object is doing in further. Then we are stating we are declaring the state as ready and replying, and this is the session number. We have also assigned the session number to this RTSP reply and sending this reply to the client, and also storing the RTP port that the client has sent. And this is the reply function that we have. This is the reply request that we have sent to the client. If the code is the OK 200, then we are sending this reply message. And here the client is waiting for the this receive RTSP reply is waiting for the server's reply. When it will send server sends the reply, it will execute, and this parse RTSP reply will function will call, and we will go to this function. Here also we are extracting the sequence number from the request the reply the server has sent, and checking that the sequence number is same as we have sent the RTSP sequence number. Then we are going ahead and assigning, if we have not assigned the session ID, then we are assigning the session ID. And if the session ID is same, then only then we are processing ahead. That if the HTTP server has responded with the code 200 and the request sent was set up, though we are changing the state to ready and opening the RTP port to capture the RTP packets from the server. So RTP port here the function is called, and we are creating here a RTP socket.af inet, and socket, and this address family is IPv4, and the socket type is
UDP, and now like we are changing the state to ready and binding this RTP socket to the RTP port. Now we will understand what is the play request. Now this setup is over. Now when we click on the play button here, so the video starts playing, and you can see here in the client we will receive the sequence number. So I am pausing for the some time. Then yeah, understanding the play button. So when the play button is pressed, the play movie function is called. So here the play movie function is there. So it is checking that if the state is ready, then it is creating a thread which is listening the RTP packets from the server, and this threading.event is created because when we it is for the pause or tear down, that if in the play if we are playing and then in the between the pause or tear down request is come, then we stop this thread. So this is the work of this threading.event, and we are sending this RTSP request of play to the server. So this send RTSP request function will again go to this function, and it will identify that request for display and the self is ready. So it will increase the RTSP sequence number and it will send the RTSP request to the server. So now server will again go to the receive RTSP request, and then it will process this RTSP request by what is the sequence number, what is the request type, and if it identifies that request type is play and the state is ready, then it will the server side is this. So it is processing the play, and if the state is in, and it will change the state to the playing mode, and it will also create first a socket to send the RTP packets to the client. So it will creating a RTP socket, and it is creating a event here. Also the schedule.event is created for the pause or tear down request from the client, and we are sending RTP packets in a different thread, and this is for the thread starting. So we will go to the send RTP function. So here is the send RTP function. In here the this wait is for that before sending a new RTP packet, wait for 15 milliseconds. So this is for that, and this is that if the pause or tear down request is come, then we will stop sending this RTP packets. So here the video stream object will come that what is the next frame. So from the video stream class, we will get the next frame as we will read the file, and what is the data from the next, what is the next frame we will get from this video stream class, and here the frame number also we will get from that video stream class. This is the address and the port number we will get that the client. This is the address and the port of the client, and we are sending this video frame to the to en, to enclose in RTP packet to the client. And when we are enclosing, we are making this RTP packet here. So this is the payload, and frame number we are assigning as the attribute. So data and frame number. So here have to make the RTP header. So we have this many fields in the RTP header: version, padding, extension. This CC is the contributor count and marker, and this PT is the payload type is equal to 26. It is predefined for the MJPEG type, and sequence number will be the what is the frame number eventually. So we will call this RTP. So we have created the RTP packet class object, and we are calling the encode method of that to create the header. So we will now go to RTP packet. So when we go to the RTP packet, it will have this header array which has 12 bytes, and we are constructing the header for the RTP packet. So here header 0, header 1 means each array box is of 1 byte, so it will have 8 bit. So in the header 0, first 2 bit it is for the version. So here we are slab shifting the version by 6 place, because you can see here like this is the 8 bit. If the version is 2, and if you store only or of these two, then it will store at 7 and 8 position. But we want to store it at 1 and 2 position. So we are left shifting it by 6 position. So this one will go here and this 0 will go here. So this is how this version is stored in the first 2 bit. Then in the third bit we have stored the padding, and in the other one bit we have stored the extension. So these are the first 8 bit. Then the other 8 bit asks for marker and payload type. Then we have 16 bits for the sequence number in. So first we are setting the first 8 bit and then the other 8 bit. We have 32 bit for timestamp and 32 bit for synchronous source identifier. So first these four are this 4 means this 4 byte is 32 bits, and we are storing the timestamp in this, and we are getting timestamp from the this time module. And then we have this synchronous source identifier of 32 bit. So this will complete our header, and we have also a payload. So we get that, and we call this get packet function, which will enclose header and payload. So this return get packet, and this will send to the client. So here in client we have seen that it is running a listen RTP. So it is waiting for the server to send a RTP packet. So then when this RTP packet is sent from the server, it will also create a RTP packet class and will decode what the data has sent to me, and it will get the current frame number from it. And so we are printing the current sequence number here. So in this you can see that when we have run the play request, this current sequence numbers are displaying. And this if condition is for like we are also storing the information about what frame number we have got. Like we have got the first frame number, then we are expecting the second or greater than frame number from one. If we have if we are frame if our frame number is 5 and we are getting the fourth frame, then we can say that it is out of order, so we will discard the late packet. And if the packet is in order, so we will update our frame number, and we will go to the displaying it to the GUI window. So this update movie function will call, and in this first we will call this write frame function. So basically the write frame function will create a cache file, which is a temporary file in which we store our frame. So it is like a JPG file. You can see here it is a JPG file. It is here, but after tear down it will be deleted. So if you want to see, it will be like a data frame file. So it will not clear here, but it will be like a JPG file. So this write frame function will do this, and this it return the what is the case file name. And in this update movie that we have called from the recent RTP, it will basically create this image file to a Tinker readable file, and it will display on the label. The label is we have created here the window there where the image will be displaying this. This is the label. So we are defining the what is the image. Um, yeah. So we are defining in the label what is the image we want to display. There this is photo and what is the height of it, and that's it. So now we can see that I have also sent the pose request. So yeah, seen that when the pose command was pose button click, the pose movie function will call, and it will also send a pose RTSP request. So here this RTSP request will send pose. So we will again increase the RTSP sequence number and keep track of the what we have sent. So we have sent the pose request, and again send this pose request to server. So this server will now implement pose request from here. It will understand, it will process this RTSP request and get that request type is pose. So it will here self.pose, and it will check that the state is playing or not. and then it will process push and it will change state to ready. And this is a threading dot event that we have called. So this dot set will stop this send of RTP function, because it is checking that if the client of event is set, then it will break. So when the pause request come, we have set this client info event. So when the pause request comes, this server will stop sending this RTP packets, and server will reply to the client that yes, I have received the pause request. And in the client, it will receive this RTSP reply, and it will go to this partial RTSP reply. So when it goes here, it will go in the pause mode and keep and change the state to ready. And it will also create here play event dot set, because we are also here listening the RTP packets. So it will also get to stop. So when it will get here, it will stop listening upon receiving the pause. So this will be false, and that's it for the pause request. And when we click tear down request, so when we click here tear down, so the here we can see that the server has received the data for the tear down, and it will close this GUI window also. So when here in the code we can understand that when we have press the tear down button, it will go to this exit client function, and it goes to the exit client function. First, it will send a request to the server of tear down, and the like here it will go to the send RTSP request, and here tear down will be the sequence number. We will update the sequence number and keep track of the tear down request, and we will close the here the exit client will self master.destroy. This will close the GUI window, and we will also remove the cache file that we have created. And in the server side, when we send the tear down request, it will process the tear down request as processing tear down, and it will set the event, because we want to stop the sending the RTP packet, and it is replying this to client that yes, I have received the tear down request from you, and closing this RTP socket. So in the here when the client receive this in the receive RTSP reply, it will know that the request sent was tear down, so it will also shut down its RTSP socket and close this RTSP socket. So after that the connection is closed. So this is it for this. Thank you.